ISC Standard 12 Subject Physics Practical according to Indian School Certificate Examination 2021 syllabus. Experiment number 1. The objective of the experiment is to determine the focal length of a convex lens by UV method. Apparatus required: 1 upright for holding lens and a thin convex lens of which the focal length is to be found out. 2 uprights for holding needles and 2 pointed needles, and 1 meter scale. The theory of the experiment is: when an object placed in front of a convex lens at a distance greater than the focal length of the lens, its real and inverted image is formed at the other side of the lens. The formula is 1 by f equal to 1 by v minus 1 by u, where f is the focal length of the lens, v is the image distance from the lens, and u is the object distance from the lens. Here is the ray diagram for determining rough focal length of a convex lens by obtaining the image of a distant object on the screen. Let's observe a video clip. This video clip determines the rough focal length of a convex lens by obtaining the image of a distant object on the screen. I consider this apartment shown in the red frame as an object which is almost 200 meters away from the lens kept on the table, and this much distance between the object and the lens is sufficient to treat the object at a distance infinity from the lens. I come back to the convex lens kept on the table, and behind that a screen is there. Here we find that a clear image of the apartment is obtained on the screen after refraction through the convex lens. Here on the screen, a real and inverted image of the apartment is clearly seen. At this stage, the distance between the lens and the screen is focal length of the convex lens. Let's note down the position of the screen and the lens on the meter scale. Here I find the position of the lens on the meter scale is 30 centimeter, and the position of the screen on the meter scale is around 50.4 centimeter. And here I record the rough focal length of the convex lens obtained by obtaining the image of a distant object on the screen. Here we have another diagram. In these two diagrams, the difference is, in the first diagram, incident rays are all parallel to the principal axis, and hence in that case the image obtained is at F on the principal axis. But in this ray diagram, all the incident rays are parallel but not parallel to the principal axis. Since the rays are parallel, that means the object is at infinity, and in this case, the image is not formed at f. The image is formed somewhere at the plane of f, where f is the focal length of the lens. Determining rough focal length of the convex lens is an essential part of this experiment, so that in what range the object pin should be placed in front of the convex lens to obtain real and inverted image of the object. Here is the ray diagram for the experiment, where the object pin is kept beyond focus of the lens to obtain real and inverted image of the object pin somewhere, and using image locating pin we find out the position of the inverted image obtained of the object pin. Now I go for taking observations one by one and recording them one by one in an observation table. I go for the first observation of this experiment. The pin shown here on the screen is the object pin. Here a lens is a convex lens, and this pin is the image locating pin. The apparatus is set properly with no parallax, and we find here that the image locating pin and the real and inverted image obtained of the object pin are matching tip to tip throughout the range of the lens. If we move our eyes to and fro, it shows the image locating pin has rightly located the image. Now let's find out what are the positions of these pins and lenses on the meter scale. I find here the position of the object pin is at 0.0 cm on the meter scale. The position of the lens, the convex lens on the meter scale is 30 centimeter, and the position of the image locating pin on the meter scale is 91.6 centimeter. Let's record these observations in a table. The observation number 1 is recorded in the table, where object pin is at 0.0 centimeter mark. The lens, the convex lens, is at 30.0 centimeter mark, and the image pin or image locating pin is at 91.6 centimeter on the meter scale. The object distance u is 30 minus 0 is equal to 30 centimeter, but by sign convention the value u comes minus 30 centimeter, and the distance between the lens and the image locating pin is v, the image distance, and here it is 61.6 centimeter. The value u minus v is minus 91.6 centimeter. U into v, the value is minus 1848.0 centimeter square. The value 1 by u is minus 0.033. The value 1 by v is 0.016. The value of the focal length of the lens by formula 1 by f equal to 1 by v minus 1 by u is 20.17 centimeter, and the magnification v by u is 2.05. In each observation, we have to find out the position of the object pin, the position of the lens, and the position of the image locating pin, and based on their values, other calculations are to be done. So about other calculations, I don't need to speak for each and every observation. Let's continue. I go for second observation of the experiment. The object pin, the convex lens and the image locating pin are set properly with no parallax. Let's observe. Here I find that the image locating pin and the real and inverted image obtained of the object pin are matching tip to tip throughout the range of the lens while moving eyes to and fro. Let's observe now the positions of these pins and the convex lens on the meter scale. The position of the object pin on the meter scale is 0.0 centimeter. The position of the convex lens on the meter scale is 33.0 centimeter, and the position of the image locating pin on the meter scale is 86.3 centimeter. Let's record these observations. Observation number 2, where the object pin is at 0.0 centimeter mark, the lens is at 33.0 centimeter mark, and the image locating pin is at 86.3 centimeter mark on the meter scale. And based on these observations, other all values are calculated and shown in the observation table. Let's proceed and take next observation. I go for the third observation of the experiment, and again these pins and lenses are set properly with no parallax, and we find here that the image locating pin and the real and inverted image of the object are matching tip to tip throughout the range of the lens while moving our eyes to and fro. Now we find the locations of the pins and the lens on the meter scale. And here I find the position of the object pin on the meter scale is 0.0 centimeter. The position of the convex lens on the meter scale is 37.0 centimeter, and the position of image locating pin on the meter scale is 81.3 centimeter. Observation number 3, values are recorded where object pin position is 0.0 centimeter, lens position is 37 centimeter, and image locating pin position is 81.3 centimeter. And rest columns are having some values which are calculated based on the observation taken. Let's proceed and go for the next observation. I go for fourth observation of this experiment. I find here the tip-to-tip match of the image locating pin and the inverted image obtained of the object is found satisfactory. Hence, there is no parallax. Now, I go for finding out at what position on the meter scale this pins and lens is there. I find that the object pin on the meter scale is at zero point 0.0 centimeter. The convex lens is positioned at 42.0 centimeter mark on the meter scale, and the image locating pin is at 81.3 centimeter mark on the meter scale. Observation number 4 is well recorded in this table, where the object pin position is 0.0, lens position is 42.0, and the image locating pin position on the meter scale is 81.3, and rest of the values are calculated based on this observation. Let's proceed and go for the next observation. I go for fifth observation of the experiment. Pins are adjusted well, and I find here the image locating pin and the real and inverted image obtained of the object pin are matching tip to tip and moving together while moving our eyes. Now I go for finding out the position of pins and lens on the meter scale. I find the position of the object pin on the meter scale is 0.0 centimeter. The position of the convex lens on the meter scale is 48.0 centimeter, and the position of the image locating pin on the meter scale is 83.7 centimeter. Let's proceed for the next observation. I go for sixth observation of the experiment. The object pin and image locating pin and the lens are adjusted very well, and I find here that the tip to tip match of the image locating pin and the real and inverted image obtained of the object pin is found. Hence, there is no parallax. Now I go for finding out position of the two pins and the convex lens on the meter scale. I find that the object pin is at 0.0 centimeter on the meter scale. The position of the convex lens on the meter scale is 55.0 centimeter, and the position of the image locating pin is 87.9 centimeter on the meter scale. Here is observation number 6, well recorded in the observation table, where the object pin position is 0.0, lens position is 55.0 and the image locating pin position is 87.9 centimeter on the meter scale, and rest of the values are calculated based on this observation only. Let's go for the next observation. I go for seventh observation of the experiment. The object pin, the convex lens, and the image locating pin are adjusted very well, and I find here tip to tip match of the image locating pin and the real and inverted image obtained of the object pin. And I find the tip to tip match is moving together. Now I find the positions of these pins and the lens on the meter scale. And here I observe that the object pin is at 0.0 centimeter mark on the meter scale. The convex lens is at 63 centimeter mark on the meter scale, and the image locating pin is at 93 centimeter mark. Here is observation number 7 recorded in the table, where object pin position is 0.0, lens position is 63.0, and image locating pin position is 93.0 on the meter scale, and the values in the rest of the columns are calculated based on these three values only. I go for the eighth and the last observation of this experiment. The pins are set very well, and here I find tip to tip match of the image locating pin and the real and inverted image obtained of the object pin. While moving our eyes to and fro, I find that the tip to tip match are moving together. Now I find the positions of the pins and lens on the meter scale. I find the object pin at 0.0 centimeter on the meter scale. The convex lens is at 72 centimeter mark on the meter scale, and the image locating pin is at 100.7 centimeter mark on the meter scale. Here is the last observation of the experiment, observation number 8, where on the meter scale the object pin position is 0.0, the lens position is 72.0, and the position of the image locating pin is 100.7, and the values shown in other columns are calculated based on the observation taken. Graph number 1. This graph is plotted between u and v, the object distance and the image distance, where object distance is in x-axis and image distance is in y-axis. And since OP is angle bisector in this quadrant and point P lies on the graph, hence it becomes a part of the observation where u is equal to v, and this is possible if the object and image are at 2f. Therefore, OA is equal to OB is equal to 2f, where O is the origin, and therefore the focal length f is equal to half of OA or half of OB, and that comes 20.25 centimeter. Therefore, the value of focal length of the convex lens using this graph is 20.25 centimeter. Graph number 2. In this graph, again the object distance u is in x-axis and the image distance v is in y-axis, and both the axes have same scale, where first u on x-axis and first v on y-axis are joined directly. Second u on x-axis and second v on y-axis are joined directly. Third u on x-axis and third v on y-axis are joined directly, and so on. We find that all these lines almost meet at a point. And here in this graph, this particular point has the coordinate -20, 20, and that represent the focal length of the lens. Hence, focal length of the lens is OA or OB, where O is the origin. Finally, focal length of the convex lens by this graph is 20.1 centimeter. Graph number 3. This graph is plotted between 1 by u and 1 by v, where 1 by u is in x-axis and 1 by v is in y-axis. The graph is a straight line which meets x-axis at the point A and meets y-axis at the point B. At the point A on x-axis, the value of 1 by u is 49 into 10 to the power minus 3, and here on x-axis the value of 1 by v is 0. This implies the value of u is equal to 1 by 49 into 10 to the power minus 3 when v is equal to 1 by 0 or infinity. It says when the image is at infinity, then the object is at f, the focus of the lens. Hence, the focal length of the lens is 1 divided by 49 multiplied by 10 to the power 3, and that is 20.41 centimeter. And same calculation we can do at point B, that is 1 by v is equal to 49 into 10 to the power minus 3 when 1 by u is equal to 0. Because the point B is on y-axis, hence in y-axis the value x is 0. That implies v is equal to 1 divided by 49 into 10 to the power minus 3 when u equal to infinity. It says when the object is at infinity, then the image is at f. Hence, f, the focal length of the lens, is 1 divided by 49 into 10 to the power minus 3, and that is 20.41. Hence, this graph gives the focal length of the lens 20.41 centimeter. Graph number 4. This graph is plotted between m, the magnification, and v, the image distance. This graph too is a straight line. The graph meets x-axis at the point A, and at that point the value of v is 20.33 centimeter. At the point A, m equal to 0. It means the magnification is 0. That shows that the image is diminished. It means that the image is formed at f. Hence, focal length of the lens is a value of v at point A, and that is 20.33. Therefore, the value of focal length of the convex lens by this graph is 20.33 centimeter. Final result. The focal length of the convex lens by mean of all the 8 values of f calculated and shown in the table is equal to 20.25 centimeter. The value of f of the convex lens by graph 1 is 20.25 centimeter. The value of f of the convex lens by graph 2 is 20.10 centimeter. The value of f by graph 3 is 20.41 centimeter, and the value of f by graph 4 is 20.33 centimeter. The experiment number 1 on light chapter, that is to find out the focal length of a convex lens by UV method, is over. This experiment has 4 different graphs, hence 4 different ways to do the calculation for the focal length of the convex lens. I hope you could understand the experiment very well, and after observing this video, you can do the experiment independently. Thank you.